So, priorities for big biodiversity data. That was actually the title of a short paper that was published last month in the journal Frontiers in Ecology and the Environment, and we'll share the paper itself at the end of the presentation. Naomi, Gary, and I were among 10 authors from different organizations on that paper, but as we were also from 3 of the 5 Eye on Earth Alliance partners, we agreed with Derek that this would be perhaps a fantastic opportunity and a fantastic topic for an Eye on Earth webinar. So today what we're going to do, each of us will take a turn speaking. We're going to give you a bit more detail on the issues raised in our paper, and then flesh out some more examples leading towards a reflection on how we see the future of biodiversity monitoring. So just to start with, I'd just like to remind us of who needs biodiversity data. And at the risk of stating the obvious to some of the participants, it's worth remembering that there are a whole range of different stakeholders need biodiversity data. One of the key ones is obviously conservation project managers who need to demonstrate and adapt their projects and measure the changes they bring about in biodiversity. Donors also need to measure the impact of their funding and the return on investments. Scientists and NGOs also need to understand species and habitats and quantify threats and plan conservation action. And also local communities need data to manage their natural resources, and increasingly businesses of different sizes also need data to monitor the sustainability of their work or their environmental impacts. And probably the biggest burden in terms of data needs and data use are on governments, because most governments of the world need data to track delivery of national biodiversity strategies, as well as their contribution to multilateral environment agreements, and of course now the Sustainable Development Goals. But that's only a part of the picture, because governments also have need of biodiversity data for a lot of other sectoral decisions as well. And in a workshop we held around a CBD meeting a few years ago, we got delegates from over 20 African countries to help us piece together a little bit the decisions that require biodiversity data. And as you can see from this list, there are issues around legislation, planning and budgeting across sectors and across boundaries. There's issues around access and benefit sharing, and mitigating human impacts and conflicts. So a whole suite of different issues and decisions for which governments require data. But as will be no surprise to many of you on this call, there are a number of ongoing challenges that people come across in accessing biodiversity data. Summarizing just a few of them here, I mean, one of the top line issues is often the lack of methods, tools, and technology. People just do not have the tools that they need to get the data they need. Also, many systems that do exist are not harmonized. And by that, I mean people are doing different things. And the problem here is if people are using different systems and different tools, it gets harder for people to share data, to compare data, and to build common capacity for those common tools. Of course, in many cases, capacity is the ultimate issue, and just not enough resources are being put into biodiversity as a whole, but certainly not into biodiversity monitoring. As a result, there are also many monitoring plans are weak, and many indicators in people's monitoring plans are weak as well. All of that meaning that a lot of reporting using biodiversity data becomes weak. Here, I've just taken one example from the Convention on Biological Diversity. If you look at the 4th national reports that most countries submitted on the left-hand side, the number of reports that had solid data was only about 36% of the total. So a lot of countries that are specifically asked and have commitments to report on biodiversity data are just not having the data they need to make those reports. Now, there are a whole range of gaps that we still find as well in the indicator sets that are out there. And in particular, we're seeing that there aren't enough measures at the moment of threats and drivers behind biodiversity loss. That's particularly important. There was a recent study that looked at mammal conservation recovery programs, showed very clearly that programs were more likely to have conservation success if the projects were both monitoring and addressing threats to species. Also, with the last CBD's global biodiversity outlook stating that 70% of current biodiversity loss is caused by agriculture, clearly we need to be measuring and monitoring more accurately as well the drivers behind agricultural impacts on biodiversity. Now, if we also look at the existing data that we have, there are gaps, which is to be expected given the challenges we have with the capacity issues. But many of the global databases that are in place have geographic, taxonomic, and temporal data gaps. And the example I just want to show you here is the Living Planet Index, largely because this is a database that has been more analyzed than most. And this is a database run by ZSL and WWF that has data, population trend data for thousands of vertebrate species. But if you look at a mapping of where those data were, there are some clear gaps. And many of those gaps are in places that have most of the species. That's many of the tropical rainforests, and of course, many of our oceans as well. A more recent study looking at the Living Planet Index also looked at the taxonomic gaps. And if you see here, what we're seeing is that it's among the vertebrates, there is definitely more data on mammals and birds, but the biggest gaps occur for fish, reptiles, and amphibians, especially those in the tropics. But data gaps don't only occur in the tropics. The State of Nature report was released last year in the UK, looking at trends in species in the UK. And even in a country where there are plenty of environmental NGOs and lots of local interest in nature, this report was only able to get species trend data for 6.5% of species in the United Kingdom. And in this case, the main taxonomic gaps were around things like fungi, invertebrates, and marine species. However, one thing I would point out here is that even with an incomplete data set, a large number of analyses and conclusions were completed. And indeed, they managed to produce this map showing the biodiversity intactness index across the UK. Okay, so the challenges are not just getting data, but it's what you do when you have the data. A number of people still struggle to get access to the data that exists in various databases. And again, that's for a range of different capacity issues, cost issues. Some people don't have the expertise to be able to either access or then use that data. Another big problem we see is that a lot of the data that is then accessed is not in a format of any use to decision makers. In other words, what tends to happen is the right people are just not getting the right data in the right format at the right time to make the right decisions affecting biodiversity. Additional problems, just before you completely give up hope thinking there are too many problems to worry about. Again, working with some African colleagues around a CBD meeting, we also identified some problems very specific to that continent, which included a real lack of cross-sectoral and interagency collaboration, a lack of dialogue between decision makers and data providers, and again, a resourcing issue, but sometimes related to weak donor partnerships. And also there are technical challenges often with things like internet connections. So those are in a little bit more detail than we put in our paper, some of the challenges we face at the moment, but it's not all doom and gloom. And I think what we now want to spend the rest of this presentation on is really looking at some of the solutions that are being produced to tackle some of these big problems. One of the contributions that IUCN has recently made to solving these problems is the establishment of the new Species Monitoring Specialist Group. This group aims to enhance biodiversity conservation by improving the availability and use of data on species, their habitats and threats. And we are working together to deliver a goal we have around making sure more decisions are being informed by proper data. Now, I won't here bore you with all the objectives of this particular group. You can look that up on our website. But needless to say, we have a set of objectives around developing and sharing tools, building capacity, data collection and use, databases and data sharing, and also enhancing the availability of data on some of the lesser studied taxa. As a result of this, we're currently setting up and fundraising for a suite of projects tackling the key issues. So in particular, we're looking at having an analysis of data and capacity gaps, field testing relevant protocols for lesser monitored species, and finding more ways to make data and tools more widely available for people that need it. Because I think what's really key about what we're trying to do, and in the spirit of the Iron Earth Alliance, is we don't need to reinvent the wheel. There are lots of people out there already doing some great work, and so while we are looking at new methods and innovations to fill identified gaps, most of the time what we're doing is working with partners to take what is already available in terms of know-how and make it available to the people that most need it. So therefore it's about working together. And just to finish this introduction, I'd like to point out these here are just some of the agencies represented by members of the Species Monitoring Specialist Group. And as well as having members in the group, a number of these agencies also have bilateral partnerships or are working together in consortia like the Iron Earth Alliance to make more data more freely available. So at that juncture, I will now pass on to my colleague Gary.
Thank you, PJ. And I just wanted to mention that what you say really resonates with the remote sensing people, because we have so many of the same challenges as you all will see. But first, I wanted to start with this image because every picture really does tell a story. And this is a picture of Egmont National Park in New Zealand, which was gazetted around 1900. And at that time, the entire area that you see here in this image was forested. But over the following decades, through maybe the 40s or 50s or so, the surrounding forest was converted to agriculture, mostly pasture land, leaving this very striking image here. During that time, of course, we didn't have satellites and could not track the change in land use here. So I wanted to show you another example, which is Don Quasao National Protected Area, which is an IUCN Category 6 area located in the south of Laos. Category 6 is a multiple use area. You can see the park boundary here, and towards the top in this area here, you can see sort of a dark area. That is the southern end of the Bolivan Plateau, and this part that's in the park is quite forested, heavily forested in this image from 1973. And if we zoom in on that, we can see the park boundary with more or less intact forest on the inside, and then the lighter green area on the outside is agricultural areas. And way up here in the corner, you can see the edge of a small city where those people are doing the agriculture in the surrounding area. What's interesting, if we look at a time series of images, we see that in 1989, we can see that some of the agriculture, mostly coffee, has now moved inside the park. Moving ahead, we see the frontier of that incursion jumps further onto the plateau, and then by 2008, basically the whole plateau is now covered in coffee. So it's an interesting sequence here. Now the reason we know this, we can't tell exactly what's going on just by looking at the images. We need people on the ground who are confirming that this is coffee and that explain really what's going on in the ground there. So what can remote sensing do for you? Well, obviously it can tell you how habitats are changing, the condition of the habitat, whether it's fragmented or degrading, or in these examples being converted to agriculture. Creating maps of land cover and indicating the different types of vegetation cover and different uses of the land is a very big application of these images. Also, it helps to identify drivers of change, roads, for example, which provide pathways for hunting and logging into otherwise untouched areas, and population centers like we saw in that image of Lao, which can be a source of additional agriculture and so forth. But it allows us, as we've just seen in the Donghua-Sao case, it allows us to monitor the change, and in some cases to actually predict what might happen in the future. Now, another thing that we couldn't see in these images is that there's all kinds of environmental information as well, such as temperature and precipitation and topography, that's also derived from satellite remote sensing. And that information, plus land cover and some other things, is very useful for what we call species distribution modeling that I'll talk about in a moment. Now, the thing with satellite remote sensing is it works by inference. We're using observations from space to infer what is happening on the ground by correlating these satellite images with in situ data. So to make good use of the satellite images, we have to have in situ data and good ground knowledge, because that's where real life is occurring. So sometimes people ask, well, then why should we bother with satellites? And it's a good question, but the answer is because the in situ data and the satellite images are just wonderfully complementary. As PJ mentioned, the in situ data tends to be, there's some drawbacks there. It tends to be local because it's collected by thousands of people and organizations globally. It tends to be somewhat patchy in space and time. On the other hand, the satellite images are global. They're continuous and they're periodic, maybe every 5 to 10 days. They're perhaps a little bit more standardized because there are fewer sources of this information. And yeah, I like to say, you know, collecting in situ data is really hard. You're out there, you're getting bitten by mosquitoes and snakes, you're squeezing frogs, and you're up to your neck in mud and so forth. For satellite data, somebody else is doing all the work, and they're paying for the massive infrastructure. But the downside there, which is a very important point, is that it tends to be quite hard to use. But overall, we have the direct and actual information on the in situ side and indirect and inferred information by satellites, so the two are very complementary. Another point to make, though, is that these are two rather different communities, and that causes some challenges in terms of the interaction between these communities so that we can extract the full value from both sources of data. But that actually is a good indicator where collaboration can be valuable. So I wanted to give you another example application of remote sensing that I mentioned, which is species distribution modeling. Basically, we might ask, where do species live? And that's similar to the question of where are the environmental conditions suitable for them to live? Now, environment isn't the only thing that controls species distribution, but it's a major factor. And so in species distribution modeling, there are really 3 steps to that. We look at where a species has actually been observed, specific observations, and there are a variety of ways to do that, but one really wonderful source is the Global Biodiversity Information Facility, which has literally hundreds of millions of observations online that we can use to do this modeling. So with those in hand, we can then correlate those observations with biologically relevant information that we get from satellite data, like I mentioned, temperature and rainfall, topography, and one of the key ones is land cover as well. And with that correlation, we can actually develop a model that describes the potential distribution of a species. And so we're basically inferring a distribution by combining these 2 sources of data. But to do that, we have to have very good in situ data. And I wanted to give you an example. It's a very simple one of an invasive species in southeastern Australia, where sambar deer were introduced from India, where it's native, around 1860. And somebody has done this species distribution modeling where they've looked at the observations and they've combined it with environmental information and land cover and so forth from satellites. And they've come up with this predicted distribution map here. They call it a habitat suitability index, where the red and orange and yellow areas are the areas most suitable and most likely to find these non-native sambar deer. And if we compare that to actual observations, by the way, not the ones we use to create the model, we see that there's really good correlation, that the yellow areas are where most of these sightings have occurred. One use for this is if you're a land manager concerned about invasive species. These deer, they don't have predators here. They eat a lot of vegetation and cause some problems, is that if we can create a potential range map where, in this case, the sort of yellow area here is the occupied range where it's now found, but the green areas are those areas where the species has not yet moved into. So if you're a park manager concerned about your park or other type of land manager, that's good information to know so you can watch out for this species and then take some management steps to control it. I wanted to show this slide again that PJ showed, just to reiterate what he said, which is we really need more in situ data because, and from a remote sensing standpoint, this helps us make much better use of the remote sensing data and extract the full value from it. Well, before I pass it on to Naomi, I wanted to just talk about the importance of continuity here from the observation system where the observations are made, that could be in situ or remotely sensed. The data then stored in a data system and then passed on to a user through various kinds of tools. But for the user to extract the full value of the observations and the data, they need to be able to have good tools that allow them to make use of that. And the problem is the actual picture is more like this, or well, probably this is a little bit more accurate, where we don't have all the tools for analysis and reporting that users need to extract that full value. So this is a gap that we really need to bridge. And we can do that through capacity building where the users become better able to use the observations and data. But actually, I think, why don't we just make those data easier to use by providing better tools for analysis and reporting. And this is particularly true for remote sensing data, which traditionally have been hard to use. So with that, then, I think that I'll pass this on to Naomi.
Okay, thank you very much, Gary. So let me just move to slideshow. There we go. Okay, so I'm just going to build a little bit on what Gary's just spoken about and talk about really how we can focus on how we can ensure that the data we're generating can be and are used in decision making. So PJ already talked a little bit about the various user groups. But I think the point I'm trying to make with this is that if we look at those user groups, they have very different needs and they have big issues around the discoverability of the data. Can they get what they need? And do they even know it exists? The accessibility of that data, can they get access to it? Is it in the right language? Is it in the right format? And the digestibility of that data, can they really understand what they're looking at and can they use it in a correct way? And I don't expect you to see the detail on this slide, but I'm really trying to make the point here that the biodiversity data landscape is really complex. There are a huge number of different data sets, different data systems out there, and it's understandable that users get very confused about the terms of use of the data, the currency, the scale, the scope, all of these things. And I just try to present one example here of, this is the Mediterranean and various area-based conservation or area-based measures within the Mediterranean. All of these are looking at different things. Some of it is areas that are protected, some of it is looking at fisheries restrictions, others are areas of importance for biodiversity. And it's really important that the user understands what they're looking at so they can use the data that's most appropriate to the decision they're trying to make. And another point around the kind of the generation of data, this is a study that was done by Lucas Joppa for Science. He looked at a whole set of different data sets and looked at these 4 different attributes. Were they freely available? Are they up to date? Are they repeated? And the spatial resolution. And if you look in the center here, you'll see only 13% of the data sets they looked at had all of these 4 characteristics. So it's really critical that people understand what they're looking at. And indeed, the compilation of those data sets can be really complex. It may come from multiple overlapping sources. So here we have an example of data collected to report on the indicator 19 for the CBD, this Convention on Biological Diversity Strategic Plan, and you'll see that the data is collected from multiple sources. This data is managed in multiple ways, and then it is brought together through the partnership and GBIF into an indicator. So it's really critical that people maintain metadata, which is information about the data. It's the supporting documentation that explains exactly how the data has been collected from what sources, and this can really help users so they're not making assumptions around the data. PJ talked about gaps in the data set, but just to expand on that a little bit, to also think about the bias in the data set. So here you'll see the similar points. We need to consider bias in data sampling: taxonomic bias, seasonality, temporality, accessibility, resolution. And here's an example of the, sorry, my circle's moved across, but you can see the abundance of records that are in the near shore here, which much less as you move out to sea. So it's just to show that, you know, just because there is no data doesn't mean that thing isn't there. It's just that nobody has sampled it. And just dwelling on this issue of metadata and publishing data, we need to get much better at publishing our data so that it is peer reviewed. We get better at publishing the metadata associated with the data sets so that people clearly understand how the data has been compiled. And again, there's a lot of detail on this slide. I don't expect you to look at it, but just to make the point that when you are considering developing a knowledge product or a data set, look at both the science implications and the policy drivers behind it, and make sure that the users are engaged throughout the process, right through from the identification of what the targets through to the development of the planning, the fitness for use, and the metrics and the generation. I'm just going to talk through one example that we maintain here at UN Environment's World Conservation Monitoring Centre, and that's the Protected Planet. Protected Planet is an initiative that's a joint project of UN Environment and IUCN, managed here at WCMC, and it is all around the delivery of one data set, the World Database on Protected Areas. But we realise that just producing a data set isn't enough. We do generate, it's a simple data set, but we also need to consider the connections, the communications with our key target audiences. We need to think of that data set in the context of the analysis. What are the analytical tools? How can we use that data to track progress in achieving conservation targets? And of course, how can we use that data to inspire solutions and change and ensure that it's being used for biodiversity conservation in the right way? So just a little bit on the database is complex because it's been maintained in some format or other since 1959. More recently, it became a spatial data set. So we have spatial information, polygons for sites, in some cases points. We have attribute information that we store in a table, and for every site we maintain source information. So where did that individual record come from and when? All of this is spelt out in our user manual, which you can get online, that provides information both for the data users but also for the data providers. We have some tips for users of the data in terms of errors they may make in analyses, and we also outline all of the standards, processes and workflows we go through in maintaining that database. And we found that the feedback since we launched this user manual has been hugely positive because it really helps people understand what they're looking at and not make assumptions around that data. Another key point about the World Database on Protected Areas is that it is updated every month. This is a constantly changing data set, and the currency of the data set is really critical. We work with all of our data providers to try and update every 5 years. Over the last 12 months, we've updated 80% of sites, but overall, we've got nearly 235,000 sites in the overall database. So it's a huge database to maintain, and it's a constant effort. And this is where the critical partnership with the data providers come in. And this is why we have the user manual. We have very clear standards for our data providers, and we have 586 sources altogether, mostly coming from national agencies and NGOs, but also from regional partners and some international organizations. And it's really important that the users, the data providers, are comfortable with how their information is being used and maintained within the data set. And this is just an example of a meeting recently that some of our team was at in the Horn of Africa, and this is working with the data providers to understand how they collate their protected areas data in the field and how that it then gets fed up into the World Database on Protected Areas, and then how we can support them when they take that data back out and actually use it for their national metrics. Another point around the users is the different interfaces that you need to provide. So on the one hand, the World Database on Protected Areas is a great way of getting block data sets from national governments, but we also have a huge number of really important conservation areas on the ground being maintained by Indigenous peoples and local communities, and they can report on an individual basis to what we call our ICCA registry, which they can then choose if they wish to have that information compiled into the World Database on Protected Areas. And we have a set interface for them. We have a whole toolkit and manual to support those communities to submit information as well. So it's really important that we are thinking about all of our data providers and users as we're maintaining our systems. And this is the primary interface. For most people, this is how they interact with the World Database on Protected Areas. We have an online mapping system that allows you to visit individual protected areas and look at their maps. And then we have some supporting information on the various thematic areas that we maintain information on. So protected area coverage, also looking at the community conserved areas, the effectiveness of areas, connectivity of areas, and the resilience, information on resilience to climate change. We also have a large area here around statistics, because one of the user feedbacks we've been getting is that people are most interested in looking at statistics at the national level and the regional level. So we built that in to our development of the system, and every year we do a user feedback survey where we say, well, how can we help you more? How can we make this better? And we add that information into our development plans. And this is just one key example. In an earlier version of Protected Planet website, people couldn't get access to the data. The key users come in and all they want to do is download the data. They don't visit the rest of the website. They maybe go and get the manual and look at what sites have been updated, but really they want the data. So what we've done is we've made that box bigger and we provide that data in more formats. And that is as a direct response to that user needs. And we have over 4,000 downloads per month now of the database. So we know it's being widely used. And we also, I mentioned previously, this request for statistics. So now we have these very clear pages for country by country outlining the percentage coverage both in the terrestrial and marine, the number of sites and various other pieces of information that can all be downloaded as a PDF and used very readily. And this is very much in response to tracking progress towards the Aichi targets and the kind of 2020 as we're moving towards that. I mentioned the users. Well, this is an example of why it's really important to keep the data maintained on a monthly basis. So we are experiencing fairly rapid growth in protected area coverage at the moment. And in April 2016, we generated an analysis for the Protected Planet report. But a year later, you can see that those numbers have jumped. So in April, we were looking at 10.1% of marine areas within national jurisdiction covered by protected areas. We're now looking at 13.2%. So this is constantly changing, and it comes back to the importance of helping users understand that this data is really changing on a rapid basis, and they need to come back and get the live data as much as possible. We also add this data into other tools, so we make it available through various formats, including through APIs. And here's an example of the integrated biodiversity assessment tool, where they have brought together protected areas information, information on key biodiversity areas, areas important for biodiversity, and species information to support decision making. And this is a partnership between multiple organizations who maintain biodiversity data sets. And indeed, we see our data being used again, through other partnerships with the Joint Research Centre, through their Digital Observatory of Protected Areas, Global Forest Watch make use of the World Database on Protected Areas. NatureServe have a very useful dashboard looking at all of the Aichi targets, again using that data, and indeed for publications, and an example here of the National Geographic Atlas of the World, which has a map of protected areas. So I'll just end on a plea to think about the users constantly in the design of any data set, any knowledge product, any analysis. Think about who the user are, why they would want to use it, and can they get access to it, can they understand it, and is there a useful delivery mechanism? And with that, I'm going to pass back to PJ to bring this all together.
Hopefully what you've picked up from Gary and Naomi's presentations is that there is hope. There is a lot of good satellite-based remote sensing data that is available and being used, and there are some very large and solid databases that are considering user needs and are being used for a range of different conservation purposes. What I just want to do now in the last 5 minutes before we open up for questions is highlight some of the other issues that we pointed out in our paper are needed to ensure biodiversity data is more readily available. One thing we need to do is to continue to fill the gaps in the indicator sets, as I touched on earlier. Indicators, especially those around ecosystem services, benefits to people, and threats to biodiversity need to be developed and used more widely. We also need to continue this drive to enhance and standardize data collection and sharing. Now, we already heard some examples of where that is happening. Also, probably some of the open access to data was started by the likes of NASA when they made their Landsat images available, and more data is becoming available. Now, I often tell people that monitoring should be as simple as possible. It's not rocket science, but in fact, clearly it is rocket science if NASA is the one collecting a lot of the data and we had to put satellites in space to start with. But the beauty is now is that not only is the data more readily available, but a number of initiatives like Global Forest Watch, like Global Forest Change, are taking that data and making it available in a format that people can use more readily. That is just habitat, terrestrial habitat data. I'd just like to flag the fact there are also a number of other initiatives making conservation evidence and data more widely available as well. But ultimately, and this obviously relates to the title of this presentation, one of our big concerns is you can't do everything from space alone. Even in 2017, we need more people on the ground getting data on the ground. And luckily, technology is advancing rapidly, and we're seeing that there are a whole range of different technologies now available for use on site, whether it's camera traps or acoustic recorders or drones, which is helping people get more data on site. What we also need are the use of standard monitoring protocols. Now, this is about harmonization. If we use the same tools, we'll more easily be able to share and compare data. And here I've just put a selection on the screen of the sorts of tools that can be used across different locations by different users. Also, ultimately, as we've heard, one of the priorities is we need to properly store and share the data. And touching on what Naomi said, we need to work a lot to make sure that we're considering user needs and making the existing databases more interoperable. But we also need to really push efforts to convert data into formats of use to decision makers. What we found, and I'm citing here some work I did when I was at WWF, but what we found is when data is put into things like dashboards or tailored reports, decision makers are more likely then to digest it and act on it. Another issue we have is that although there are a number of existing databases out there, most of them, whether it's Protected Planets, the IUCN Red List of Threatened Species, or the Living Planet Index, most of them are underfunded. And so one of our pleas, if you like, as well, is to try and ensure that we don't keep seeing a proliferation of measures and platforms. We try and build on what we have and only build new technology where there is an identified end user need. Last but not least, people talk a lot these days about citizen science. We quote in our paper eBird because there's a huge number of observations collected by members of the public going in there every month. But obviously now the proliferation of apps and mobile devices around the world also means there's a lot more potential to exploit citizen science. And what's also been shown is that if you involve more local stakeholders in the collection of data, then that data is more likely to be used in decision making and used more rapidly. And last but really not least, and the point I'm always strongest on, if we are going to get anywhere, there needs to be a concerted effort by the conservation community to build the right enabling environment, especially in countries with most of the biodiversity. We need to rally together to build national capacity to increase resourcing for in-situ data collection. We also need to develop capacity and tools so that people can develop their own derived products and interpret data for decision makers. And we need to make sure throughout this process that the scientists and the policymakers are talking to each other. Now, if you read the scientific literature, there's a lot of discussion of science, policy interfaces, and boundary organizations. But what it basically means is more of the stakeholders need to talk to each other. More of the people collecting the data, whether it's in situ or remote sensing, need to talk more with the people that are actually using the data in order to come up with the products that will ensure the data are used. So there you go. Hopefully we haven't overwhelmed you too much in this brief presentation. We crammed a lot in. There is a lot to be done, clearly. Many people are quite daunted by the challenge, but I hope we've shown that it doesn't have to be a daunting situation. Much of the satellite-based remote sensing data are now freely available in formats of use, and as we've seen as well, technology is increasingly available to get data on the ground. But I think, again, I would just underline more than anything that even in the 21st century, we need now more people on the ground in key sites, such as protected areas, such as key biodiversity areas, to count animals and plants and assess the threats facing them in order to ground truth the data that we can get from space. In order to do that, we need a concerted effort by the conservation community to work together to help build capacity for data collection, sharing and use in the countries with most of the biodiversity. Methods don't have to be expensive. Often it's literally just training that's needed to get people going. And when we do finally have more trained people on the ground, we will be able to produce more of the data we need to improve environmental decision making and then ultimately enhance the impact of conservation action. So thank you very much for listening patiently to the three of us. We appreciate there's not lots of time for questions, but we are open to receiving emails and feel free to get in touch if you have anything else to ask us you aren't able to do now. So thank you. Back to you, Derek.
So now I invite Dr. Frederick Launay, Senior Advisor at the Environment Agency Abu Dhabi and the Director General of the Mohammed bin Zayed Species Conservation Fund to respond to our speakers on behalf of the Eye on Earth Alliance.
So thank you very much to the presenter, to the three presenters, for a very entertaining and informative presentation on a very complex and apparently daunting challenge of data for species monitoring and conservation. I mean, this is something that was really at the core of the formation of the Eye on Earth movement in 1992. When the Abu Dhabi government decided to launch the Abu Dhabi Global Environmental Data Initiative. This challenge, especially for developing countries, of accessing and obtaining data on biodiversity as well as looking at ways to use it. And it's still very much a topic, as you've seen in the presentation, which is of actuality. So the three speakers have shown the challenges and issues, the proposed tools, certain solutions that could be implemented, as well as an example of database and the way they are potentially being used by the wide community of practitioners and users. From my place as both working in an environment agency, which is a government agency, which is responsible for a lot of the reporting, as well as the director of the Mohammed bin Zayed Species Conservation, who is a donor in species conservation, The main thing we've been noticed, and I'll try to be very brief, and because it's already been mentioned by the various speaker, is one of the key challenges we face is the increasingly low number of people who are knowledgeable about species in the field and who are able to actually do this ground truthing validation of species monitoring. And that's really critical. It's increasingly difficult to find people who are trained and able to perform these tasks. The second thing, from a decision maker and policy maker, we've got a challenge of speed and time frame. Very often species monitoring, species data are very long to collect, very hard to collect, and it takes a lot of time to actually analyze in a form which is relevant for decision maker. So the speed at which the data are collected and make their way to a form and a format that are useful for policymaker is very, very important. One thing which is also increasingly important is actually probably not to try to go too far in analyzing and assessing data for policymaker or users. There are as many use and needs that there are species nearly, so it's infinite. So it's absolutely impossible to try to predetermine what a policymaker or for end user would need data for, or even which set of data it will be needed. But what is critical is to have access, increasing the accessibility of raw data and metadata set. Then leave the end user or policymaker or decision maker do their own analysis in a more adequate way, trying to foresee what policymaker will require or are requiring is extremely difficult. It's nearly impossible task. And finally, I would like to say that we tend to look at data very much from our own sector. The conservation work and the conservation people will look at data gathered and analyzed within the conservation community. We very rarely look outside our community to look for data from the industry, from the user group, from a different perspective, development agencies. And these are data which are there, collected in a different way, in a different form, but are also very much useful if they are placed in a different context. So cross-sectoral data integration is also very, very important. So I don't want to take more time. I would again would like to, on behalf of the Eye on Earth community and all the people who have been listening to the talk, thank our three speakers, and I will hand over now back to Derek.
We have many, many questions. The first questions came from a regular attendee of our webinars, Dr. Ahmed Madavi from the University of Tehran.
About overlapping maps. Some years ago, there was some kind of overlapping maps from EPA about the hot toxic spots on endangered threatened species. I mean, how the maps are overlap on each other. Are these type of maps developed to see real, and especially for the protected areas, to see how much the toxic, pollution are affected on the endangered or threatened species. This is especially that it was mentioned about that also 70% of the loss is due to the agriculture. That's another thing, I think. But so about the map, are these type of maps developed?
It was a mapping question. I was going to put it to Naomi.
Okay, I'm not sure I can respond actually, but because I'm not aware of any the data sets you're referring to on mapping toxins, but theoretically we could quite, I would imagine quite readily take the protected areas data that we have, and if there is a spatial map available, overlap the two. And actually, what I'll ask is to get your email address, because what I'll do is I'll talk to some of my colleagues who are in the process of doing a lot of work looking at mapping pressures and threats to biodiversity globally, with the hopes of ultimately building, making those maps available readily online. So if I could get an email address, what I'll do is I'll set you up with one of my colleagues who'll be able to respond to that query more quickly. But in theory, yes, that's absolutely possible if we had the data, but I am not aware of it being done recently, and it's a really interesting point. Thank you.
Thanks a lot, Naomi.
There's a question from Salima Mahmoudou. Salima, if you wanted to put your question, I think you have a couple of questions there. Would you like to put your question to the speakers, please?
Perfect. Thank you so much for this great presentation. I have a couple of questions regarding some of the origin of the data and whether or not it was standard across different countries. So one, are your data mostly global or national? And if they're global, what's the process of getting them validated at the national level? Because I work with the Global Forest Watch, and that's sometimes what we find being the most difficult, because we work so much at the global level, but sometimes it takes a lot more efforts to get them validated at the national level. And Gary, what are some of the remote sensing tools that you use, and how do you work with governments or country personnel to get them trained, or even to understand these technologies because of access to internet, access to these technology, or simply the understanding of these technologies? And my last question, sorry, is regarding standard surveys for biodiversity. Are these surveys, is there a standard survey or data collection available in each country, or is Protected Planet providing a survey that whoever is interested in collecting the data could follow? Thank you.
Shall I take the question on the, I can respond in terms of the data collection for Protected Planet, perhaps, in terms of whether the data is getting global data validated. The mechanism for collation of Protected Planet is that the data comes from national governments. It's primarily information on protected area coverage, and it is reported through various kind of international mandates from governments to us. So actually it is national level. It's national level data that's aggregated at the global level. And I think that's quite an important point, so that we're not developing data, we don't change the data. It comes from the national governments or other national agencies that are collecting it, or other partners within country, and then is aggregated up at the national level. I mean, in terms of the species data, maybe PJ can respond, but it really depends on the country. In terms of protected areas data and species data, every country collects their information differently. And so you really have to, this is why it's critically important to maintain the source information, so you understand where that data's come from, you maintain the metadata so you understand how it's being compiled. It's really critical to look back through that stuff and not just take a global data set at face value and use it. But PJ, do you want to respond in relation to the standardized surveys for biodiversity?
Well, essentially, of course, it depends on which database you're talking about, but that was one of the issues we tried to get across today, was the fact that unless people in different countries are starting to use harmonized methods, then this does become an absolute nightmare when it comes to collating it. But I think it's fair to say that certainly with IUCN and the red list, we make every effort to make sure that data is coming nationally, or is always the priority. I think we've realized that from the start, but there does have to be a huge amount of effort to harmonize systems. Otherwise, it does become incredibly difficult to validate and compare. And I don't know, I think, is Gary gone now? Because I think he might have had something to say on both harmonizing data and the tools he used. Gary, you still there?
I am still here, yeah, thank you. And thank you for that question, or those questions, Salima. I think one of the questions was regarded training and tools. In terms of training, there are actually lots of organizations, including NASA, that have a variety of different capacity building workshops to help people understand remote sensing data and some of the tools to use it. And that's great. We need that. But I'm still a firm believer that, you know, let's also at the same time make the tools easier to use. When people get trained, what I hear from the people who do this is that only around half of them ever use remote sensing data again. So in terms of making the data easier to use, I worked with the USGS some years ago to encourage them to make the satellite images available as georeferenced JPEGs, because a lot of people, all they needed was, for example, a picture of their park. And at that time, they couldn't even get that easily. And so now the USGS now makes Landsat data easily available as a georeferenced JPEG. And so for someone who just needs an image, that's I think, a good path. What we're still missing, I think, are tools that can generate derived products from remote sensing data, or maybe combining remote sensing data with in situ and other sources of data as well. And also, and that's related to that, I think putting more models online that can help to combine these things and help users ask, for example, what if kinds of questions, we still need that. Now, having said that, there are a variety of different tools out there that allow users that may not be you know, your typical graduate student who can spend a lot of time learning the tools. There are tools out there that can help people interact with images and build images of various kinds and use them for applications, but I think we still have a ways to go. But if you're interested in what some of those tools are, I'd be happy to send you a list of the ones that I'm aware of.
Thank you.
Thank you for the question. I'm conscious of time. There are a number of questions along a similar theme. Dawn Phillip in the University of West Indies in Trinidad and Fatima Kais are both asking, so if you don't mind, I will put the question on their behalf. Very briefly, any thoughts on addressing marine species? Obviously, with remote sensing, there are some challenges with dealing with penetrating much in the way of water depth. But any comment from the speakers on, in response to Fatima, Dawn, and other people who are interested in using these methods for marine species and habitats?
Well, maybe just on the sort of broader species perspective, one of the projects we're undertaking at the moment that I referred to earlier is we are doing a global audit of data and capacity for species. And I mean, one thing that is already coming up, and I showed you a bit from the UK report, for example. I mean, they were short of marine species data. Pretty much every database you look at when it comes to species, anything under the water is not as well recorded. So that will become a focus of the species monitoring specialist group's work in coming years. We will definitely make sure that marine and aquatic species are given extra attention, because so many data sets that are out there and so many marine or aquatic sites are short of data, certainly when you compare them with terrestrial sites. And as I showed you too, even in the LPI, the Living Planet Index, fish were among the most poorly known vertebrates as well. It is a challenge. Obviously, it's because it's difficult. I mean, it's hard enough often not getting to terrestrial sites, but if sites are underwater as well, there are some extra technical challenges there, but they're not insurmountable. And we will certainly be doing our best. I should also just note that organisms like corals as well, even though they are probably better monitored than some marine organisms, we can also make more headway there as well. But it is an ongoing challenge we will try and address.
Right, thank you for the answer. Sabrina, Anita, Sabrina, you had a number of questions here. If I could ask you to kind of put the question in the general sense, the one about data quality and data concerns. Sabrina, if you I've opened your mic.
Yeah, so actually there are only two questions. The first is how we can sustainably curate the big data, because there are data that are not really reliable in terms of coordinates or all features like that. And the second one is how can we promote people to share the availability of the data, because there are actually many biodiversity assessment in the tropics where the data gaps are, but they are not willing to share it because of copyright or privacy reason, and there are not any published data also on that. So that's all. Thank you for the opportunity.
Thank you, Sabrina.
I would defer to one of my colleagues on the curating big data. Is this protected planet? Is that a good example of how you iron out some of the quality issues, Naomi, perhaps?
Yeah, I mean, am I muted? No. It's a really good question, and it's a really, really challenging thing, because, I mean, linked to that is also the sustainable financing of these kind of data sets. So we find that the quality diminishes the less funding you have, and so there's just a constant challenge in trying to maintain the data sets, put in sufficient quality assurance mechanisms, but also to actually work with the data providers. So we find that if we can work with data providers, help them understand our requirements, if we can understand their requirements and their resource challenges, then we can make it much more straightforward. But one of the things we've found with the World Database on Protected Areas is that if we simplify, the more we simplify, the easier it is to ensure the quality. So really looking at databases and saying, well, what are the core pieces of information we really need? What are the key pieces, what are the key attributes that everybody needs to maintain with that site? So in some countries, they'll maintain massive data sets with an enormous amount of information about their sites. But what we do is we pair that right back and we say, well, what do we actually need for our purposes? And the more you simplify, the more straightforward, the more you standardize, the easier it is to maintain the quality. In terms of the currency, that's really, again, very challenging, because in some cases, data is being updated on a very regular basis. In other places, you can look at you know, a data set, for example, the global data set of mountains is 10 years old, but that's okay because that mountains haven't moved very much. So, you know, there's some things don't change, but the things that do change, you need to be really on that and constantly improving it. So it is really challenging, but I would say to simplify, make it really clear what your data standard is, and then just try and work with the data providers, so you're providing them with something that's useful for them, and they're providing you with something that's useful for you. It has to be a two-way flow.
Perhaps I'd just add too, I mean, that issue about how you encourage people to share. I mean, there are several papers looking at all the different motivations about why people aren't so keen to share, and I still meet some scientists that just say, you know, I don't want my life's work just to be incorporated in some big database, and maybe I'll have my name somewhere on an 80-authored paper. There is some of that still going on. I think the sort of solutions we need to look at, we do need, as Naomi was saying earlier, to find more ways of publishing data to make it citable. I mean, one thing IUCN did with the red list, for example, was to turn red list assessments into documents in space and time, if you like. They used to be just on a website, but now you can download PDFs. Each one is given a DOI number, so a digital object identifier, I think, is that the right acronym? But so now that authors of those red list assessments and data within them can get some credit, which wasn't always the case in that particular situation. So I think we have to be a bit imaginative in this, and not imagine that everybody is going to be happy to hand over their data without some sort of acknowledgement, but I think we are getting better at that.
Thank you for the question and the answer. We do have still on the call someone who is managing or facilitating access to one of the largest collections of biodiversity records that I'm aware of, which is GBIF. Tim Hirsch is in the audience. Tim, I've seen you put a couple of questions. We are we've massively overshot the time frame here, but I wonder if you just wanted to make a brief comment and observation. Your mic is open, Tim. Tim? I think Tim must have stepped away from his mic. His mic is open, but will. So I think that I'm going to ask, there's one more person I would like to put his question for reasons that will become apparent in a moment, and that's Pierre Buttigieg. Pierre, if I can just quickly unmute you and you could put your question, and the reason I'm allowing Pierre is in fact the speaker at our next webinar, so it's a nice segue. Pierre, if you wanted to put your question.
Right, so the question is to everybody, actually. So I'm from the Albert Beckner Institute for Polar and Marine Research. We also do deep sea research based in Germany. I'm just asking about communities doing multi-omic sensing or metagenomics and eDNA methods to detect species. Just wondering if that's on the radar, and if they are on the radar, or even if they're not, how would the best approach look like to interface with your communities and your efforts?
Well, maybe I could kick off on that. We only touched in the time we had available on some of the most obvious methods and tools and issues out there. Certainly when it comes to the latest technology and species monitoring, we do need to get into aspects such as DNA monitoring and so forth as well. That is something that we are not yet engaging on while we undergo our prioritization exercise. However, it's clear that that is one of the issues we will look at how best to tackle, but it's certainly on our radar. We just didn't have time to mention it today.
Thank you very much.
Thank you for the question, Pierre. And one last try with Tim.
It's not Tim Hirsch, it's Dmitry Shigel from the same office, from the GBIF Secretariat. It seems like Tim has some technical problems. We are a little surprised that Global Biodiversity Information Facility has been excluded from the presentation by the PJ, otherwise great. Global Biodiversity Information Facility exists as an intergovernmental infrastructure bringing together primary species-level data using common standards and sharing protocols. And the biodiversity informatics community, TADWAKE, exists for several decades to technically enable this data sharing. So we would very much recommend the audience looking at the recently developed sampling event standard as a mean to share the monitoring data and link to individual sampling events based on defined protocols, able to record relative abundance and so the changes over time as promoted by GeoBon. So those interested in this can visit gbif.org and contact us at GBIF for technical details on this. And the global community of data holders of the long-term monitoring programs and plot and transect systems is getting together for the first meeting in Leipzig in about a month from now to shape the campaign for the sampling event data. So these data will be aggregated globally, and we are looking forward to working together with IUCN and other stakeholders in making this data globally available in the standardized way.
Great. Thank you for that response.
One comment there is to say that, as I said earlier, we weren't able to touch on everything, but I explicitly didn't mention GBIF because both Gary and Naomi did in their presentation. So I hope the people that were following picked up on the fact that that was referenced at least a couple of occasions as a major database. But as I said earlier, we weren't able to mention in detail every single one.
Thank you. I'll bring it to a close at this point. There are still plenty of questions in the queue, and I apologize to those who didn't get a chance to put the questions. But as I said, they are logged, and I will pass them to our speakers. It's been a fantastic webinar. Thank you so much, everyone, for joining. Webinars are what we as a community make them. Thank you again to our speakers. who put in an enormous effort to prepare this very extensive presentation. Bye for now.